start the recording. Okay.
Okay.
So now I'm recording. Go ahead.
On number 8, do you have your book with you?
Yep.
Okay. On number 8, it's like sine.
2.8.
Yeah, 2.8.
Okay.
2.8.
Yep. Sine x squared.
Sine x squared, and then can you use the product rule for that?
No,
No. Okay. No.
because it's sine of a function. So it's sine of something. It's not sine squared of x. But yeah, if you don't, can everybody see the computer or not? Or like not everybody's logged in?
I'll put you at the photo.
Okay. But you got to leave.
Oh.
Maybe we should use Jack. Or
Stuffy,
something.
do you want to get on later when I leave?
Yeah.
Stuffy will get on when I leave.
Okay. All right. No, that's fine. So I'm going to go to the whiteboard, and I'll just give you a couple. So the biggest thing, there's a lot of, there are a lot of trig problems that they like to throw in with this, but I will show you so everybody can see my board now, whiteboard.
Yeah, we got you.
Okay. So if I have, let's just do an awkward one that they probably aren't doing. Let's do, well, let's do let's say f of x equals tangent squared x. Now that doesn't look like your problem, right? But I could rewrite this as tangent of x quantity squared. That's really what that means, right? For tangent squared x. Agreed? So if I take the derivative of this using the chain, this one I use the chain rule because I'm going to act like it's okay. So that it's a function to a power, right? So I'm going to act like it's okay, and it's going to be 2 times that thing to the first power times the derivative of what's inside, right? So the derivative of tangent is what? Secant squared, correct? So that's the chain. So this gets attached there by the chain rule. And I do like to use different colors for this. But anyway, and then secant's 1 over the cosine, right? So the reality is this is, so it's just 2 tangent secant squared. Otherwise, what's tangent? Tangent is sine x over cosine x. And then secant is 1 over cosine, so this is 1 over cosine squared x, right? The red one is that. So if you really wanted to, you could call it, this is equivalent to 2 sine x over cosine cubed x. I don't like that any better than 2 tangent x secant squared x. But your job is to match the answers in the back of the book, right? And if it ends up being a simpler version of how you write it, great. I don't think it is. So personally, my final answer on this one would be 2 tangent x secant squared x. Okay, everybody good with that? That's the one that I like. I would just leave it like that. It doesn't get much better. Now, you could also, here's another thing that you could do on this is we have, what do you know about secant squared? That's tangent squared x plus 1, right? Everybody agree with that? That's one of the trig identities. Just like sine squared plus cosine squared is 1. So if I wanted to, I could plug that in, and then if I multiply the 2 tangent x times that, another equivalent answer that I'm going to use purple for would be 2 tangent cubed x plus 2 tangent x. Everybody see how I got that one? You just multiply 2 tangent x through times tangent squared and then times the plus 1. Now, is this one any better? It's 2 tangent cubed. No, it's just in terms of tangent, right? Things like that. Not really that great. That's not any better either. So once again, this black answer that I have here, I like the best of just 2 tangent x secant squared x, okay? So that's one. So that's tangent squared x. Let's look at a different example that's kind of like what Luke said. If I have g of x equals tangent of x squared, well, that's not tangent of x times tangent of x. This is tangent of x times x, right? So it's different. We got to square the x first and then take the tangent. So if I'm going to take the derivative of this thing, okay, so I don't know if I said you can't, I don't know what your question was. If you said, can you use a chain rule? We have to use a chain rule, but basically we act like it's okay. So what's the derivative of tangent? You guys should know this off up here. Secant squared, right? So it's secant, so you act like it's okay. So the derivative of tangent is secant squared. Secant squared of what? Of that thing. But then, because that is not just an x, I have to take the derivative of that thing. So the derivative of what's inside is the derivative of x squared, which is times 2x, right? And that's by the chain rule. So with that being said, then what's this equivalent to? So it's equivalent to 2x secant squared x squared. And really it's secant squared of x squared, right? So you don't need those parentheses though. But anyway, so the answer is 2x secant squared x squared. Do you see the difference on tangent x squared and tangent squared x?
Yeah.
Okay. Now, if you don't like that, that's when we can do things like, whoops, what was that? Let me put it back up. G of x equals what I have, tangent of x squared. And if I say, hey, you know what, I'd really like to rewrite x squared. If that was tangent of u, the derivative is secant squared u, right? So if I let whatever, z, I'm going to use z, let z equal x squared, right? Then I can say dg, sorry, use a different color. The derivative of g with respect to x, that's what g prime is, right? G prime at x is the derivative of g with respect to x, but I could write that as the derivative of g with respect to u, not u, z. I called it a z. Derivative of u with respect to z times derivative of z with respect to x, right? So the derivative of g with respect to z, this is equivalent to tangent of z, right? Well, the derivative of tangent of z is secant squared of z. Do you agree? With respect, so the derivative of g with respect to z is secant squared z. And then the derivative of z with respect to x is just the derivative of x squared with respect to x, which is 2x, right? But then what we can do is we can sub back, and we know that z equals x squared, and plug back an x squared here for that z, and put it all in terms of x. So it's secant squared of x squared, and then times 2x, which is the same answer that we had before, but that's a little easier on the eyes if you write it as 2x secant squared x squared. Okay, so Isaac was kind of the only one that initially said, hey, I kind of like doing substitution or doing a dummy variable. You can always do a dummy variable. You could always peel it apart using composition of functions and then the definition of that. But I'm going to try and use concept on that, you know, every time.
I'm starting to like chain rule more.
So we actually use a chain rule. We do use a chain rule on that, though, on number 8. Yes. But you don't do it. It's different than sine squared of x. Right? Sine of x squared is not the same as sine squared x. See, act like it's okay. Take the derivative of sine of that thing times the derivative of that thing. So that thing is x squared. So if you want to work on that, now we get number 20 gets a little more complicated, right? I have tangent squared of x squared. That's a little different. I also had you do that one for tomorrow, didn't I?
Yes.
You want me to do number 23, or did I did 23 yesterday, didn't I?
Yeah.
I could do one like number 10, but change it. Let me do that. So here I got capital G of x equals, well, this is secant squared of x, but instead of making it, I'm just going to say it's like number 10 because it's not number 10, right? So it's secant squared x squared. So we can do that. Now, if you were going to rewrite this, you would rewrite it as what quantity squared? Secant of that thing, quantity squared, because secant squared of this is secant of that quantity squared, right? I mean, if I let x squared be u, secant squared u is secant of u quantity squared, but u is x squared, right? So let me rewrite that. It's secant of x squared quantity squared, right? That's what this squared, secant squared means, right? So if I want g prime at x, I'm going to act like it's okay. So it's something to the second power. So use the power rule, right? So it's 2 times that thing to the first power. So secant of x squared, then the quantity to the first power times the derivative of what's inside, right? So I got to take it times the derivative of secant x squared. Well, the derivative of secant is what? Secant tangent of that thing, though, right? Of that variable. So it's secant x squared tangent x squared. That's by the chain rule once, but then since it wasn't just an x, I also have to take it times the derivative of what's inside, which is x squared. So times 2x, and that's also by the chain rule, right? Sorry, I hate this board because I run out of room. But does that make sense? So I have a function within a function, so I got to use the chain rule twice. But that x squared is not just a variable. It's not just an x, it's an x squared. So I had to use the power rule initially. So I drop that 2 down in front, times derivative of that, or times this to the first, times the derivative of what's inside, but really I'm taking it times the derivative of secant, which is secant tangent, but then I got to take it times the derivative of what's inside that, which is x squared. Derivative of that is 2x. So for my final answer, then what's my final answer look like? It's going to look like I'm going to pull that 2x in front, multiply it times 2, and I get 4x. And then secant x squared times secant x squared times tangent x squared, right? Secant times secant is going to be secant squared x squared, tangent x squared. So this is a final answer that would be okay. And then once again, what's tangent? Tangent sine over cosine of x squared. Sine x squared over cosine x squared. Secant's 1 over cosine x squared. So if I really wanted to, for any stupid reason, I don't want to, but it'd be 4x sine x squared over cosine cubed of x squared. Now that's not any better, but this is the answer that I like there. But in this case, you got to use a chain rule within the chain rule. So guess what? For number 20, you got to, and 24, you got to use the chain rule within the chain rule. Number 20 you do for sure. Number 24, you might have to do it 3 times. You might have to use a chain rule within a chain rule within a chain rule. You see why I wanted to meet you guys today?
Yeah.
Tim, is sine squared, is the derivative of that 2 sine or is it 2 cosine?
Sine squared.
Yeah.
So let's let f of x is sine squared x.
Mm-hmm.
Just taking the derivative of this, f prime at x, you're going to act like it's okay, right? So I'm going to drop that down in front. So it's 2 sine x times the derivative of what's inside. Well, the derivative of what's inside is sine. Derivative of sine is cosine. So it's 2 sine x cosine x. Did I do something that wasn't that earlier? Or that's, you were just asking? This is not number 8,
Part of
by
the
the way. This is,
Part of the difference.
what's that?
This word.
All right, Tim, I have to go. I'm gonna shut you
Yep,
off.
no problem. Yep. Have fun. Reach out on WhatsApp if you guys have questions. You know, and I'll help you tonight. You know, if you really have some issues, I'll help you at the beginning of class tomorrow too. But you know, I want everybody to give their best effort. This stuff's awkward until you get a feel for it, but you got to do odds and make sure you get those answers.
Okay.
You know, do some odds.
Bye.
See ya. Yeah. I kind of went through some of these in my videos too, I think. But anyway, once again, I can rewrite this as sine of x quantity squared, right? So basically take that 2, drop it down in front, act like it's okay, 2 that thing to the first, and then times the derivative of what's inside. Derivative of sine is cosine, so that's the and I like to write it above here, but this is the chain rule right here. Let me look at another one. Well, actually, I got to make sure it's not one to turn in. But this is one you should know. If I have, let me go to back in black, baby. So let's look at the derivative with respect to x of sine squared x plus cosine squared x. Well, this is kind of a fun one because what's the answer? Don't know, do you? So let's figure it out. So the derivative of the sum is the sum of the derivatives, right? So for the first part, I'll do the first part in red. So I'm going to act like it's okay. We just did this one. It's 2 sine x to the first power times the derivative of sine is cosine times the derivative of what's inside. So that's a chain rule, right? So we just did this one. So you must agree because it was sine quantity squared. And then cosine quantity squared, I can do the same type deal. This is cosine of x quantity squared. So act like it's okay. It's 2 cosine to the first times the derivative of what's inside, which is derivative of cosine, is minus the sine, right? And guess what we get here? What's this equal? Anyone? Anyone? Bueller? Bueller? Kylie, you're the only one there because I don't have anybody in the class.
Where'd they go?
Well, Isaac left and then nobody else logged in, which is kind of why I told him, but that's all right. It's recorded. But anyway, these are the same thing, opposite sign, right?
Yeah.
So this is 0, correct?
Mm-hmm.
Now we should have known that because what is sine squared plus cosine squared?
Wait, that's the trig.
So,
Not
So-
wall.
hey, Lee,
What?
just a second. No problem. So anyway, this is a trig identity, so it equals 1, right?
Yeah.
Okay, so what's the derivative of 1 with respect to any variable?
0.
0, right? So we kind of made that hard, but this is a proof that it's 0,
Yeah.
right? So anyway, if I recognize that identity, then that was a little bit easier. So
Yeah.
do you want me to do one more that's a little more involved? Like a
Yeah, I
number,
wouldn't mind.
okay, like a number 21.
Okay.
I don't think I did that one yesterday, did I?
I don't think so.
Okay, so tangent squared x minus x squared quantity cubed. I'm going to take the derivative with respect to x of that.
Yeah.
Okay, so basically I have a function in here. Okay, so it's a function to a power. So the derivative is going to act like it's okay. It's 3 times that thing to the second power times the derivative of what's inside, right? So what's inside is tangent squared x minus x squared, and then I have to take it times the derivative of what's inside. Well, the derivative of what's inside is a difference of two functions. So taking the derivative of that, it's going to be the derivative of the first one minus the derivative of the second one, right?
Mm-hmm.
So the first one, though, it's going to be, that's tangent of x quantity squared, so it's going to be 2 tangent of x to the first power times the derivative of what's inside. So the derivative of tangent is secant squared, right?
Yes.
So that's using the chain rule within the chain rule. And then minus the derivative of the second one is just 2x. Correct?
Mm-hmm.
So it ends up being this. We can multiply stuff out if you want. I don't know if it makes it any better. I'm going to look at the number 21 here. This is section 2.8.
Yeah. Here, let me see.
21. So what all they did is pull the 2 out
Yeah.
of this out front and attach it with a 3, and they made it 6 times tangent squared x minus x squared quantity squared, and then times what's left is tangent x secant squared x, and then minus x, right? So that's all they did for their answer. The other thing we could do if we really wanted to is square the first part out, multiply everything through. That's going to get awfully awkward, so I don't like that at all. And the other thing too is when we have tangent x secant squared, sine over cosine times 1 over cosine squared is sine over cosine cubed. That is not a better format than tangent x secant squared x. So anyway, so they just pull that constant out in front. You know, if for some reason we end up with something like secant squared plus 1, or excuse me, tangent squared plus 1, or secant squared minus 1, secant squared minus 1 would be tangent squared, because we have all of those things where we have like sine squared x plus cosine squared x is 1. We knew that one. Divide everything by sine squared, and we get 1 plus cosine over sine is cotangent squared x equals, and 1 over sine is cosecant, right?
Yep.
So 1 plus cotangent squared x equals cosecant squared x. If I divide everything by cosine squared x, I get tangent. Sine over cosine is tangent, so it's tangent squared, not theta. Tangent squared x plus 1 equals 1 over cosine squared. 1 over cosine is secant, so it'd be secant squared x. Right, because if you square 1, it's still 1. But anyway, so these are really based on this this one. We have 3 different identities, and if you remember this one, you could figure out the other ones. I did that in class, but The first one, I just divided everything by sine, both sides by sine squared x.
Mhm.
And of course, dividing the left, yeah. It's like that. Okay. All right. Well, I think we're at the end of the normal class session. So unless you have additional if you do have additional questions, reach out. I'm going to stop recording, and then make sure, you know, my goal is, like, you guys really haven't let me help you outside of class much at all. I mean, some individual, like you have, but, like, you know, there's some individual questions and stuff, but I'm willing to help the class on WhatsApp. So whenever, how do I stop sharing that?
Yeah. I didn't quite